Hello, scientists! Welcome to another edition of Mr. Bones and I Are Bored. Now let's get Mr. Bones to light up a little bit so we know he's paying attention. So, Bones, what should we do? Say what? Soap bubbles? You want to blow soap bubbles? Oh, I actually happen to have some soap bubbles right here. Soap bubbles are awesome. You can do so many things with them. But what exactly is a soap bubble? What makes that bubble stay a bubble until it's not? Well, a soap bubble is nothing more than a gas that is encased in a sphere. And in the case of a soap bubble, there's actually 3 layers to a soap bubble. On the inside is a layer of soap. In the middle is a layer of water, and on the outside is another layer of soap. Just like that one. Yeah, well, Bones, blowing bubbles is fun, but these things are small. What if we want to make some big ones? I like making really big bubbles. Let's see what we can do. That's what I'm talking about. Yeah, look at that. Oh, that's a beauty. That's what I'm talking about. Now that, my friends, is what I mean by a bubble. And one more. Woo-wee! So why is soap needed anyway? I mean, why can't we just try to make bubbles with regular old water? I mean, if we stir it up a little bit, I see there's some bubbles on the top. But let me see if I can blow just a plain old water bubble. It doesn't work at all. Well, and why is that? It has to do with surface tension. Now you might think then, well, if we increase the surface tension, then we can have a stable bubble and we can make a really big one. But the problem with water is the surface tension is so great that it doesn't like to be pushed out into the shape of a sphere. A water molecule has a positive end and a negative end. When a negative gets near a positive, they're going to want to hold on to each other and not let each other go. So that doesn't make for a very good bubble because they don't want to release each other. And when you blow through a wand that has just water on it, the water is going to just clump together and not make that nice sphere that we associate with a soap bubble. So what the soap does is actually relaxes the surface tension in the water so that it can spread out a little bit. But the soap also provides support for the water to take on that sphere shape. And that's how we get our soap bubble. So why does my soap bubble pop? Well, there are 2 things that are happening. One is gravity. And if you look at your soap bubble, you can see the soap molecules in the water are being pulled down by gravity, causing a weakness at the top of your bubble, so it eventually pops. The other thing is evaporation. So as the water inside evaporates, it's going to lose its shape and pop as well. That's why blowing bubbles in a very dry environment is not as easy as blowing a bubble in a very moist environment where there's a lot of humidity. But bones, these bubbles are really small. What if we wanted to make some big ones? The answer to that is, along with having some soap and having some water that we can just pour into any old pan. I'll pour in a little bit of water. I'll pour in some dish soap. I'll stir it around. And I've got my bubbles. Well, what if you don't have a special wand like this at home? You can make a wand out of anything, almost anything, that has some kind of shape to it. Here's a can, lid of a can. This is a little harder because the circle is so big, but you get the idea. So it's something else that would be fun to experiment with. But most bubble solutions, where you make those really, really big ones, along with having the soap and the water, you need to add something else. It's called a polymer. And polymer is a molecule that repeats itself over and over again, just like slime, just like plastic. It gives it some shape, all right, and it holds it together. Now, I don't think you could dump in some plastic into your bubble solution and think that it would work. But there are lots of things that you can use at home that can work as a polymer. And one of them is actually corn syrup, right? Another one is a food ingredient called gargum. And if you add just a teaspoon of this to your bubble solution, it's going to greatly increase the strength of your bubble. I got my eye on this styling gel. I'm wondering if this might work. Your assignment this week is to follow the scientific method to figure out which that extra ingredient into your bubble solution is going to make the best bubble. All right, so we're going to keep our soap and water the same. And when you begin, you might want to start with, say, 4 cups of water to a half a cup of soap. And see if you get a good bubble with that. After that, you could begin adding your other thickener or your polymer and see what happens then. Now, it might take a little bit of experimenting, but the bottom line, if we're going to follow the scientific method, is that we start with our control, being the soap and the water, and then we add one variable. And then we see which one is the strongest. And I hope that you all want to make a really big bubble, so you're going to find that one ingredient that's going to make an even larger bubble than just the soap and the water. But you might be wondering, okay, how am I going to measure it? And I don't really have a good answer for you. I've got some ideas, but one of your challenges for this experiment is to figure out how you're going to measure it. Will you be able to measure it with numbers? Will you measure it with observations? Could you measure the size of the bubble when it lands on a dry surface? You can measure the diameter. So those are all things you're going to need to think about as you're playing with your bubbles. And what more fun is there than playing with bubbles? All right, have fun. I look forward to some very interesting data.